Hello. We are going to go through our last section here in Unit 2. The title is to prove angle pair relationships. We're going to learn quite a few theorems and finish the section with a proof. So let's start out with the vocabulary. We are going to add pictures here, but there are, you can see 4 theorems and a postulate. So these theorems will show up in proofs. So I'm going to highlight the name of them because it is something I want you to come back to and know the name. And then remember at the back of your notes packet, there's that list of definitions, postulates, theorems, properties, things like that that you can refer to. Okay, the first one is the right angle congruence theorem. And it just says that all right angles are congruent. So you might wonder, okay, why do we need a theorem to say that? The reason we have this theorem is there's a lot going on with a right angle. So we know that a right angle is 90 degrees. So without this theorem, we would have to go through the process in a proof of saying that a right angle is 90, your second right angle is 90, the two 90s are equal by substitution, and then you would have to turn around and say, okay, those two right angles are congruent. So this theorem allows you, if you know you have a right angle and you're trying to show them congruent, you can go straight to that reasoning. Okay, the next two are pretty similar. The first one is called the congruent supplements theorem, and then the congruent complements theorem. Okay, so they're the same idea. It's just one deals with supplementary, the other is complementary. So if two angles are supplementary to the same angle, or two congruent angles, then they are congruent. So let's just draw a picture here. Draw yourself an angle, kind of like this, and I'm going to call it 80 degrees. Okay, I'm going to draw a second angle here that I'm going to label 100 degrees. And then I'm going to draw a second 80-degree angle over here to the side. And let's also just give these angles names. Let's just call that angle A, angle B, and angle C. Okay, so what this theorem says, first of all, notice A and B are supplementary. They add up to 180. C and B are supplementary. So this theorem says if you have two angles that are supplementary to the same angle, those two angles have to be congruent to each other. So if A is supplementary to B, and C is also supplementary to B, well then A and C have to be congruent to each other, just by the way the math works on supplementary angles. Okay, so if two different angles are supplementary to the same angle, then those two different angles are equal to each other. The congruent complements theorem is the exact same idea, only it deals with complementary angles. Okay, so I'm just going to put 90 degrees right here. So if you have two different angles that are complementary, then those two separate angles have to be the same amount, just by way of how the math is going to work. Okay, linear pair postulate. And we've already talked about this one actually, but it is a postulate. If two angles form a linear pair, then they are supplementary. Okay, so we talked about that earlier. It's a little bit more basic than, say, a theorem. So if you have just a reminder on a linear pair, if two angles form a linear pair, they are along a straight line. So if we just call this angle 1 and angle 2, the linear pair postulate says that if angle 1 and angle 2 form a linear pair, then they are supplementary. So I'm going to say here, angle 1 and angle 2 are supplementary. Okay, so like I said, we have talked about that. We just never really put a name to it, but it's called the linear pair postulate. And we've also talked about this next one, but again, we didn't put a name to it. The vertical angles congruence theorem says that vertical angles are congruent. So let's draw a picture of two intersecting lines. And then I will just name the angles 1, 2, 3, 4, just number them. So I can see on the picture I have vertical angles. So the angles that are congruent, angle 1 and angle 3 are vertical. So therefore angle 1 is congruent to angle 3. 2 and 4 are vertical, so angle 2 is congruent to angle 4. So again, this one we'll see in proofs a little more often than linear pair postulate, but it is a theorem that gives us that property, I guess. Okay, well, we're going to do a little bit of kind of find the missing angles, fill in the puzzle, and then we're going to end with a proof. Okay, complete the statement. Given that the measure of angle BHD is equal to the measure of angle CHE is equal to 90. So both of these angles are 90. So let's find those. BHD. Okay, so I'm going to put a right angle here. Okay, BHD. And then maybe I will switch colors here. CHE. Okay, so this is going to look a little weird, but I'm just going to put a big right angle there so I don't forget. So all 5 of these answers rely on this. Now, all 5 of these answers, like, they start over. So angle 1, excuse me, the answer for angle 1, I cannot repeat going forward to figure the rest out, okay? The only information I can use every single time is this. Okay, find the measure of AHG. So I'm going to kind of use my pencil and find the angle in case you are having a hard time finding the angle. AHG. Okay, so AHG is this angle down here. So my big blue angle. So if this is 90 degrees up here, this one down here is also 90, okay, because they're vertical. Plus, if this is 90, these are perpendicular, and all 4 of these big quadrants are also going to be 90. Okay, so we'll kind of keep that in the back of our mind, 90 degrees. The next one is CHA. CHA. Okay, so CHA is over on the left. That's also 90 based on what we just talked about. All right, if the measure of CHD is 31 degrees, CHD. So I'm going to put 31 up here, because remember, 31 won't necessarily apply for the next problem. Then find the measure of EHF. EHF. I'm going to put like a star right here. Okay, let's see. What do we know? There's going to be multiple ways to do this. All right, there's 2 things we could do. So what I want you to do is look at this red angle here. So if BHD is 90, then DHF is also 90. So this side is also 90 as well, all right? Okay, we can use the congruent complements theorem here, and let me show you how we can do that, or we can use a different way. So if we know that the angle I put a star on, and this angle over here, DHE, if we know these 2 are complementary, and then we know that 31 degrees is also complementary to this same angle here, well then these 2 angles have to be congruent to each other. That has to be 31. The other way to do it is just use complementary angles. So this big blue angle, if this is 31 degrees, then this angle down here is 90 minus 30, they're complementary, or 31. So this angle here is 59, okay? And so we know DHF is 90 degrees. So if this is 59, then we can turn right around and do 90 minus 59, we're back to 31. So that's why we have that congruent complements theorem, because that's how the math works out. Okay, so that means that we said this angle was also 31 degrees. Okay, next one. BHG, BH down to G. So I'm going to go like this whole angle opening right here. Okay, so that's 125. Find CHF, CHF, so from here to here. So can you see the relationship between this one and then this one? Those are vertical angles. So if you can kind of mentally block out all the other rays that are in the way, this angle and this angle are vertical. So that means they are congruent. So that is also a 125. All right, and then one more, EHF. EHF. So this one down here is 38. BHC, right here. Okay, I mean, there's going to be a lot of ways to do this. I'm going to focus on this line, okay? So if I have a line, I know that it's a straight angle. So that means if I go like this, like kind of this big arc, all of these angles along this line have to add up to 180 because straight angles are 180 degrees. So this angle plus this angle plus this angle plus this angle should be 180. So this is 38. I have this big right angle here. So these two together make 90. So I'm just left with one more. Okay, so I could, one way to do this, take the total, take away 38, take away the 90, and I'm left with 52. Okay, so that last angle over there is 52 degrees. So one thing that's going to be really important, especially when you're dealing with homework on a computer screen, I would really recommend you copy down pictures so that you can write all over them. You're going to want to mark angles because visually you're looking for, you're looking for those verticals. You're looking for angles along the line so that you can add all those pieces up. Okay, I'm going to stop this video, but what I want you to do is I want you to complete this example here before you start the next video, and then we'll work through this proof together.